Okay, so we're back and we have electric field is what I want to talk about next. So protons and electrons, or positively charged particles and negatively charged particles, it doesn't have to be individual protons and electrons. If they have a charge, they're going to have an electric field. Protons are going to have an electric field that radiates outward from the positive charge. You can see that in this picture right here. All those arrows are pointing away from the proton. And then for our electron, it's going to have an electric field that is pointing inward. The electric field is how different charges talk to each other, how they interact with each other. Electric fields are not forces, but they cause different forces on protons or electrons that are introduced into their electric field. So let's see what that looks like exactly. I have these two proton and electron with, let's see, with their electric fields. If I go ahead and introduce an electron over here for the proton and a proton here, and then an electron here and a proton here. First off, I know that opposites attract. So without doing much work, I can figure out that this electron is going to be attracted to this proton, and this proton is going to be attracted to this electron. Opposite or same charges are going to repel each other, so this proton is going to experience an electric force away from this proton, and this electron is going to experience an electric force away from this electron. And this is how I would draw it. So these are my electric force arrows, and I'm going to place them on the particle that I introduce into the system. So this just puts into words how an electric field interacts with positive or negative charges. One important thing here is that the positive charges, if you introduce a positive charge into an electric field, it's going to experience an electric force in the same direction as the electric field. If you introduce a negative charge, it's going to experience an electric force in the opposite direction of the electric field. Okay, so Coulombs law is how we figure out the magnitude of the force. So we figured out the direction. Now we want to know how much force it's experiencing. And this over here on the left-hand side is Coulombs law. If you notice, it looks very similar to the force of gravity equation. So we have force equals a constant here, Coulomb's constant. Coulomb's constant is equal to 8.99 times 10 to the 9th. Then that constant times the particle charges, the absolute value of the particle charges, divided by the distance between them squared. So let's go ahead and practice a few of these. Oh, before we move on, it's important to note that 1 coulomb is quite a bit of charge. That's 6.24 times 10 to the 18th electrons or protons. Protons and electrons have the same amount of charge, just in opposite directions, which means that 1 electron has a charge of 1.60 times 10 to the negative 19th coulombs, which is very small. So let's do this problem. A positive charge of 0.5 coulombs is 2 centimeters away from a negative charge of 0.2 coulombs. What is the magnitude and direction of the electric force experienced by each charge? Well, it's a positive charge and a negative charge, so it's going to experience force towards each other, but let's see what the magnitude is. So I have Coulomb's law. I set it up, so I plug in my constant, 8.99 times 10 to the 9th. I then plug in my charge of 0.5, multiply it by 0.2. Again, it's the absolute value, so that's going to come out to be a positive 0.1 divided by 0.02 squared. So I'll get 8.99 times 10 to the 9th times 0.1 coulombs divided by 0.0004 meters squared. When I work out those numbers a little bit further, I end up with a force of 2.2475 times 10 to the 12th newtons. That's a lot of force, but these are really heavily charged particles here. Okay, we're going to go over one more problem in the next video, and then you'll be good to do your homework.